Hi guys, welcome back to Calculate videos. In this video, we're going to talk about a very good calculus trick and shortcut that no calculus teacher told you about. In this video, we're going to talk about this kind of integral where we can see the f of x function on top and also on the bottom. And also there's no restriction over the upper limit and the lower limit. Okay. So in this case, as long as we met these requirements, then the value of this definite integral is going to be equal to 1/2 times b minus a. 1/2 times upper limit minus the lower limit. Okay, all right. Normally, if you try to solve this kind of definite integral where there's no restriction over the upper and the lower limit, with the traditional way, it's going to take at least 3 to 4 minutes to bring it down. But with this method being used, it's going to take only 30 seconds. So I'm going to show it to you. So let's get started. First of all, as you may notice that we see 2 to the power of sine x on top, and also we see 2 to the power of sine x on the bottom. So we met the first requirement. Then we need to meet this requirement also. F of a plus b, so lower limit plus upper limit minus x should be equal to this one. So let's check that. So f of my upper limit, in this case my lower limit is 0, 0 plus pi over 2 minus x. Okay, so it's going to be equal to f of pi over 2 minus sine x. Okay, and if I put it into the original function, we're going to get 2 to the power of pi over 2 minus sine x. Okay, and then this expression is going to be equal to, from the trigonometric identities, it's going to be equal to 2 to the power of cosine x, which we got this expression right here. So we met the second requirement, so we can continue. So this integral from 0 to pi over 2, it's going to be equal to 2 to the power of sine x over 2 to the power of sine x plus 2 to the power of cosine x is going to be equal to 1/2 times upper limit pi minus 2 minus the lower limit 0. The answer is going to be equal to just pi over 4. Okay, so we got two requirements that we need to meet. The first, we should see the f of x function. F of x function should be on both top and at the bottom. And also we need to test this function if we get this function. Okay, so using the upper and the lower limit. Okay, and we tested it. And then using the trig identities, this expression is going to be equal to 2 to the power of cosine x. As long as we got these two requirements met, then we went ahead and continued. So we got this expression. Apply the formula, and then we got this expression, pi over 4. Okay. So in this video, we're going to solve 3 problems. We've just solved the first problem, so let's move on to the second problem. In the second problem, what I see is integral from 1 to 2 square root of x divided by square root of 3 minus x plus square root of x. So basically, the very first thing that got my attention is square root of x. So I see square root of x on both and at the bottom. So which means f of x is going to be equal to my square root of x. Okay. Then I need to try upper limit 2 plus the lower limit 1 minus x. So we're going to check that if that's equal to square root of 3x. Okay. So the f of 3 minus x. So if I take this and switch the 3 minus x with x, the expression is going to be equal to 3 minus x. So alright, so we got the second requirement met. So now we can continue. So the integral from 1 to 2 square root of x divided by square root of 3 minus x plus square root of x is going to be equal to 1/2 times upper limit 2 minus the lower limit 1. So the result is going to be equal to 1/2. Okay. Again, I'm going to repeat the same thing. So we got two requirements in order for us to be able to apply this formula. First, I should be able to see f of x on top and on the bottom. And also I should be able to verify this expression, if that's equal to the square root of 3 minus x or not. As long as I got these two requirements met, then I can continue and apply the formula, and the results is going to be very easy. Okay. All right, let's move on to the third problem. In the third problem, what I see is e to the power of cosine x. Okay, let me use a different color. So e to the power of cosine x divided by e to the power of cosine x plus e to the power of negative cosine x. So notice that what I see twice on numerator and denominator is e to the power of cosine x. So basically f of x e to the power of cosine x. Since I see this on both numerator and denominator, so my first requirement is met. Okay, so let's check the second requirement, which is f of lower limit plus, upper limit plus lower limit minus x. So which is f of pi minus x. So now let's put this expression into the original f of x function and see that if it's equal to e to the power of negative cosine x. So e to the power of negative cosine pi minus x, and that's going to be equal to e to the power of cosine x using the trig identity. Okay, so one of the famous trig identities. So we got the second requirement met. So my integral from 0 to pi e to the power of cosine x divided by e to the power of cosine x plus e to the power of negative cosine x dx is going to be equal to just 1/2 times upper limit pi minus the lower limit 0. So answer is going to be equal to just pi over 2. Okay. All right, guys. In this video, we've talked about this definite integral trick or shortcut that is going to come in handy a lot, especially when you take the competitive exams about math. So thanks so much. If you like this video, don't forget to subscribe, like, share, and comment. In the next video, we're going to talk about another integral shortcut method. See you in the next video. Bye-bye.